Welcome to today's webinar, which is first one on technical writing webinar series. I'm so glad to invite my good friend and longtime working partner, Professor Xianming Shi from Washington State University, to talk about 6 key elements of high-quality technical writing. Before we start today's webinar, I would like to inform everyone the webinar will be recorded and uploaded on Center's website, and we will start the webinar presentation first. And if you have any questions, please type in the question. You will see the questions box, and at the end, answer your questions one time. And this webinar series is co-sponsored by CESTiCC, ISCIP, and 3 units. Presenter Dr. Xianming Shi currently is an associate professor in Civil and Environmental Engineering Department at Washington State University. He serves site director for 2 Tier 1 university transportation centers. CESTiCC is one of them. He has a lot of titles, so I don't want to mention all. He has about 20 years of research and teaching experience in multidisciplinary topics. He has authored or co-edited 7 books and authored or co-authored more than 160 peer-reviewed journal and conference papers with a H-index of 37. His research has been sponsored by numerous agencies, for example, National Science Foundation, different departments of transportation, U.S. Department of Transportation, National Research Council, and private sector, with a total budget of over $10 million. 2 of his papers were the highly commended award winner at the Literary Network Awards for Excellence. Also, one of his papers was the 2011 to 12 Best Paper by SCE Journal of Code Regions Engineering. Also, one of his projects won the AASHTO 2016 Sweet 16 High Value Research Project Award. Especially recently, there's a new journal which is launched by Springer Nature this year. Dr. Shi is the founding editor-in-chief of this journal, named Journal of Infrastructure Preservation and Resilience. I'm so glad he will share his personal thoughts and observations based on his years of experience about technical writing. Dr. Shi, now it's your turn.
All right. Thank you very much, Professor Jinny Liu, and thank you everyone for taking the time to attend this webinar. I hope in the end you find the time is worthwhile, I guess. So again, my name is Xianming Shi, faculty member at Washington State University, and the talk, I actually have given the talk in some similar form at different locations, but this is the time trying to do a webinar to reach a broader audience. The topic is 6 key elements of high quality technical writing. So to begin with, I actually was given the topic a number of years ago by a collaborator to help the grad students. So I was thinking about, okay, how do we define high quality? So that's the first question coming in mind, because nowadays we look at impact factor maybe too much. So high impact factor of journal, does that mean the high quality of the paper published in that journal? I would say not always, because some topics are more popular at the time and maybe get more citations, or maybe the journal was widely marketed. Now, another thing is the high citation of the paper itself. That might indicate some level of quality, but again, also depends on how popular the topic is. For some not so popular topics, even a low citation number doesn't really mean the quality was low. The other 2 metrics I was thinking about, okay, intellectual merits and broad impacts. Those are the 2 parameters often used by the National Science Foundation to look at technical proposals. or proposed ideas. So I think they, look at intellectual merits more like whether or not the findings or the work will advance the knowledge base, on the subject area. And the other one, the broader impacts look beyond intellectual benefits. So we're looking at, okay, potential benefits to the industry, to the practitioners, or even to the broader society. So those are, of course, very difficult to measure or quantify, but I think they're getting closer to my definition of high quality. Now, a simple way, I think, to look at high quality, just search at the bottom of your heart, feel like, okay, if I publish this work, will this be something I'll be proud of for the rest of my life? Because if that's the case, that means your work is creating value, so you won't fool yourself. Or is this something I will be ashamed of or regret when I'm more established researcher, or when I retire, I wish I'd never published that piece of work. So that's a very simple criteria, in my opinion. So that gives us the indication of, ethics, of course. In other words, something popular at the time may not directly speak to the quality of the work. And the ethics is always important. Before I get into the 6 elements of the high quality technical writing, of course, especially for beginners, these are basically rules in the field. Avoid plagiarism. Don't take other people's work and claim your own credit, and credit where credit is due, and try to avoid any sort of fabrication of data or modification of data or partial use of data. I'm sure there are plenty of other talks out there about the ethics, so I just want to briefly mention that. Now, here's another slide I borrowed from my colleague, Dr. Jennifer Adam at WSU. So this one talks about what is fraud. So there are many different forms of fraud. Sometimes, again, it's very subtle. It's not directly, taking things from others, but sometimes you're just paraphrasing without, even if it's given credit, but it's basically using different words to say the same thing. That's a more subtle form of plagiarism. Now, sometimes people may want to hide a certain procedure or detail of the procedure. That's also fraud. Or trying to get rid of certain data points which doesn't, support the theory or the key finding, and just inconvenient truth being dumped. That's also fraud. But of course, there are scenarios where we clearly state our rules. Say, hey, based on this, criteria, these data points are considered as outliers. As long as we clarify that, that's okay. So just a few little, scenarios about fraud, and then we move on to the key elements. Well, again, these are from my personal thoughts, not necessarily from any textbook, but we know that the general process of research typically starts from identification of a topic, and then move on to literature review, look at what has been done, we don't want to reinvent the wheel, and then propose a hypothesis, and then based on the hypothesis, would develop some methodology and action plan, and then execute the plan to collect data and analyze data, and then write a report or the manuscript. Now, in this process, I highlight 3 steps, which are, in red fonts here, because I think those are the 3 steps which make the most difference. In other words, pretty much any person with good training can do a decent job with other steps like literature review or methodology writing, developing methodology or action plan. But to identify the right topic is crucial, actually. We'll get to that when we talk about innovation. And yet another thing often being ignored is hypothesis. People tend to develop plans without a hypothesis in mind. So by end of the work, it's hard to say what the findings, how the findings could be useful, because they're just creating additional data points, not necessarily clarifying anything in the knowledge base. Now, of course, today we'll talk about the importance of technical writing. So the writing also makes a huge difference in terms of how you communicate the message effectively to your audience, engage them and get them interested and inform them so that they can save time before they move on with that knowledge or message. So here are the 6 key elements I kind of put together based on my personal thoughts and observations. Of course, you can see that the fonts are in different size. That kind of implies my level of, my rating of importance. So innovation is huge. That takes about 40% of the space probably. So we'll talk about innovation, because if a topic is not innovative, no matter how good a writer you are, that piece of work or manuscript won't be very helpful to others. We'll get into more details about that one. And then the second keyword I will talk about is engaging, in terms of your tone, how you communicate in your technical writing. And then the third one is hypothesis. The fourth one is logic. We'll talk about logic between different sections, between different paragraphs, between different sentences. That's one thing I think people often didn't realize. Maybe they're writing well, but they didn't realize. Interesting thing is that for my kids when they were in elementary school here in the United States, they were already trained about flow of logic. I was actually shocked when I first heard about that, because when I was a PhD student in China, I don't think anybody trained me on flow of logic. But anyway, the fifth one is synthesis. We'll also talk about that in terms of why we need to look at other people's work when we tell our own story. Now, the final one is details. Of course, as we always say, the devil is in the details. So to begin with, why we need innovation? Nowadays, for a typical cover letter to a journal, for instance, when we submit the manuscript, after we say, hey, we'd like to submit this work, which has been prepared to meet the requirements by the journal, usually what follows is a so-called novelty statement and an abstract. So the novelty statement, for some journals, is a required statement. It's one sentence. Just tell us what's new, why this piece of work is deserving attention or publication, because there are already many other similar studies out there. How is this one different? How is this one making unique contribution? So innovation is the first step. In reality, more and more journals are test rejecting a lot of manuscripts. What that means is the editors or the associate editors put their heads together and look at that manuscript and say, hey, maybe this is not innovative enough. We don't want to waste any time of peer reviewers. They reject right away at that stage instead of moving on to peer review, official peer review process. So novelty statement. So before we even start planning our work, we need to think about, okay, if the work is successful in 1 or 2 years, what would be our novelty statement? Because then you have very clear goal and clear, articulated novelty statement there in the very beginning. Of course, in the cover letter, we often emphasize, again, the ethics, for instance, manuscript has not been previously published in whole or in part, and not under consideration by any other journal at this moment. And also all the authors are aware of and also accept responsibility of the manuscript. So those are the common things in the cover letter. Now, if we start from the first key element or keyword, innovation, how do we come up with innovation? My personal thought would be there are a number of ways. The first one is to follow the cutting edge, either in science or in technology domain. For instance, if there's a new theory coming out, maybe we can think about whether or not we can apply that theory to our individual field. Or if there's a new tool, for instance, the advancements in ground penetrating radar has reached a certain point, and maybe we can use that technology to identify distresses in pavement or bridge decks. So by following that cutting edge, you can come up with innovation. That's one way to look at it. Another way is what I call needs-driven innovation or needs-driven research. What I mean by that is if you are a practitioner or you work with practitioner, you understand there's a real need in the industry or from the practice, then we can derive some sort of question from the practice. Again, that's where we could formulate some sort of hypothesis and design some plan to explore or test that hypothesis. Now, yet another way is to be able to cross the borders of disciplines, because sometimes we become almost the slave of our own knowledge, so that we can not reach beyond, especially in the era of information explosion. It's so hard to keep up with all the advances in your own discipline, let alone keeping up with the other advances in other disciplines. But it's kind of nice occasionally to reach outside your comfort zone, because that will help us in a number of ways. For instance, we can better identify the knowledge gaps in our own field, look at the issue from a different angle or as an outsider, take one step back and look at the overall landscape. Another way or another benefit of cross-disciplinary research or exploration is to be able to identify research area and subject. Like I mentioned earlier, the first step in good research is to identify the right topic. So keeping up with the most interesting problems or cutting-edge technologies or theories in even other disciplines might inspire certain thoughts that will help us transform our own discipline. Now, the third benefit is be able to challenge or greatly enhance current understanding. One example I want to give is actually a personal experience. Was one time I was reading a textbook, and I'm sure it's a very good book. In the foreword, it was talking about the flash concrete. So it was saying, okay, basically, you shall not use more than 30% flash to replace cement in concrete, otherwise you'll have early age strength issues or free soil durability issues, which was an okay statement. But again, if you just comply with that current understanding and didn't go further, then we wouldn't have the newer advances like we have today, like high volume flash concrete, which use more than 50% of flash to replace cement in concrete, and also the geopolymers, which is 100% flash geopolymer, so no cement in that concrete. So in other words, we should not blindly trust that text in the textbook just because it's well-established knowledge. Because behind that statement, there's some reason. There's some best understanding or best practice at that stage. But things always have more room for improvement. So be able to think outside the box and challenge or greatly enhance current understanding is important. In other words, before you plan the work, think about if the work is successful, whether or not you'll be able to add a new section to a textbook to be written in 5 years or 10 years, or maybe even dramatically change how that chapter will be written, or maybe even add a new chapter. That's how you tell whether or not your work is incremental or transformative. The worst kind of research, of course, is you're looking at an old problem using old theory and old method, and that's not going to benefit pretty much anyone. So, for instance, the knowledge is very clear. You are just adding additional data points to support the same theory, same conclusion, then that's not innovation. That's basically a waste of your life, the life of peer reviewers, and the life of the readers. So again, I use the example of flash concrete in that textbook to illustrate that oftentimes to come up with innovation, we need to be able to raise reasonable doubts. For instance, if they say, okay, you shall not use more than 30% of flash to replace cement in concrete, then we should question that current understanding. Why did they come up with this conclusion? Always ask the question why. Don't take the conclusion and run with it. Because we found out the reason they didn't recommend more flash was because much of the additional flash, say once you reach beyond 30%, the additional flash tend to not participate well in the hydration process. Now, if you move from the traditional Watson ratio, say 0.5, 0.4 down to, a different zone, phenomenon will disappear. Now, especially with the aid of super plasticizers or other concrete admixtures, the whole chemistry or dynamics in the fresh concrete mixture could change. So the paradigm was shifting, and the traditional wisdom no longer hold true. So there's always room for improvements. Just keep in mind that nothing is written in the stone. And for PhD students especially, sometimes my interview with students come up with this image. Basically, we're so into that subject of the dissertation, we became, somewhat tunnel vision. Like, okay, this is the thing I'm going to do for the rest of my life. But in reality, grad school or even college was just trying to provide you the ability or cultivate the ability to learn, the ability to identify problems and solve problems. So it's not necessarily that same subject. It's more the ability to be able to immerse yourself into a subject, but also be able to step back and look at the bigger picture. So again, try to be a master of knowledge instead of a slave of knowledge. We all fall into this trap at times. Now, another way to look at innovation, again, earlier I mentioned, okay, most journals or many journals nowadays require an innovation or novelty statement. Think about whether or not you can come up with that statement easily. Now, and also basically whether or not you're able to potentially challenge the current textbook or add a key section to it. Basically, these are the type of studies that would make the biggest difference. They will differ themselves from the mediocre or incremental work. So again, talking about transformative versus incremental, one way to look at it is just imagine a scenario. Your paper is published, and 10 years down the road, somebody accidentally deleted this paper from the entire database of the universe. So would that make any difference? If the state of knowledge remains the same with or without your paper, then why are you doing it? So something to think about. Now, innovation, like we mentioned earlier, one way is to look at multidisciplinary collaboration or cross-disciplinary exploration, or what I would call transdisciplinary thinking. Because many of the issues in the real world is cross-cutting. For instance, if a bridge deck is deteriorating prematurely, it doesn't care whether you are a materials engineer or civil engineer or environmental engineer or industrial engineer or electrical engineer. What you need is a holistic solution. A holistic solution requires often multidisciplinary collaboration. Now, the reason I say it's transdisciplinary thinking is that by crossing the disciplinary, you explore and collaborate, you reach out, and in the end, the knowledge will actually transform your own discipline. One example is the use of non-destructive evaluation technologies like ground penetrating radar or ultrasonic waves, many other techniques. But now with that kind of, by introduction of those type of technologies, which traditionally belong to, say, defense industry or other industries, we introduce them into civil engineering field, and then we may be able to transform some of the traditional wisdom we have. And also the introduction of other tools like data mining or artificial intelligence into our traditional civil engineering field definitely will make things better and inspire new ideas. So with this type of thinking, we will be able to shed new light on a subject which could have been studied to death in the last 50 years. But now all of a sudden we have new tools or new way of thinking. It would also enable us to go beyond the traditional how to the question of why. The reason I say that is engineers tend to focus on solutions. So we focus on the question of how to fix this problem, how to improve, how to come up with a more cost-effective additive or material or design. But then if we move beyond that to the question of why, sometimes that will enable new insights. For instance, there were many, I would say maybe at least a dozen studies looking at different sealers for concrete decks, how they perform to enhance or improve durability of concrete structures. So we ended up doing one a couple of years ago, and then my postdoc was like, okay, product A was the best, F was the worst, we can write a paper and publish. True, we can certainly write a paper and maybe even add some fancy tools like SEM to say, hey, this is interesting. But I challenge him to go one step further, like why A is the best and F is the worst. Because I know that the product A is a shifting target. Same with the product F. Because the companies had behind the trademark, they will modify their formulations. So the knowledge, if without the question why being answered, the knowledge will be very short-lived. So once we get more into it, we realize, okay, maybe it's the water absorptivity, the gas permeability, a number of other things that determine the performance of the sealer. In that case, the knowledge is no longer formulation dependent. So that knowledge could be much more transferable to other cases and guide the practice of other developers of sealer products, for instance, or to help the agencies like Department of Transportation to come up with test protocols that can quickly tell a good sealer from a bad sealer without running extensive, year-long tests. That's just one example. Now, with this kind of transdisciplinary thinking, one could also cultivate a more holistic way of thinking. In other words, many real issues have multiple dimensions. And traditionally, because the topic for a PhD or for a project is narrowly defined, or we want to drill in deeper, and then we forgot to take that step backward and look at the overall bigger picture. Now, one example about innovation is the use of nanotechnology for more durable and sustainable concrete materials. This is a slide I adopted from Professor Surendra Hashar a number of years ago. So in order to achieve really good performance, long-term performance for nano-modified concrete, it takes a lot of new thinking, a lot of innovations to occur in many different ways. For instance, better characterization of the material itself at multiple scales, and also the development and application of new materials, and also the use of sensors to better understand what's really going on at the microscopic level, for instance. So it's a civil engineering subject, but it certainly could use a lot of knowledge from other disciplines to shed new light on this subject. Now, moving on to the second key element of high quality technical writing, I would say it's engaging. Because in any sort of writing, we're trying to communicate the message effectively. So it's really important to adopt the right attitude. Basically, we're having a conversation with our reader, almost one-on-one. And everything we do in the technical writing is to make the job of the reader easier. That's why later I'll talk about the use of topic sentences, the importance of flow of logic, and all those things. In today's world, again, people will not have the time, most likely they won't have the time to read every sentence of your paragraph before they figure out what's going on. Very unlikely they'll read every sentence in your article, but first they'll scan through it. So to make their job easier, you should have very clear structure of telling your story. Now, tell an engaging story with cohesive structure. That's also important. What I mean is that your introduction section should always correspond with your key findings, for one thing. I've seen a lot of papers in the introduction. They start with something really, large scale, like national economy level, and then talk about many different questions or doubts or challenges. And then when you look at the key findings, they don't answer the questions raised in the introduction. or they don't clarify any of the debates they raised in the introduction. So it's not cohesive, it's disjointed in that case. So at least my preference, I guess everybody has a different way of writing a paper, but my preference would be start with results and discussion. Don't write introduction in the beginning. Because once you have results and discussion, then you can find out what are your key findings. Key finding 1, 2, 3. And then you look at your introduction. Okay, of course, you always start from why the subject is important. You know, how is your work or our work innovative, different from, you know, all the existing work. And then you should move on to, you know, the key findings. Basically, if key finding is that, for instance, nano modification was able to significantly improve freeze-thaw durability of concrete materials, then probably in the introduction, you would have something like, you know, nanomodification, the impact of nanomodification on the freeze-thaw durability was unclear or debatable. There's inconsistency in the existing literature or things of that nature. So again, the cohesive structure should, you know, tell the story really consistently, not disjointed. Now, with that order, you can write an introduction that makes a lot more sense. And then, of course, we can move on to abstract. Abstract usually is kind of highly condensed to look at, okay, why the subject is important, what methodology we used, and, you know, move on to some key findings and maybe even some sort of concluding remark. Again, the importance of the tone. I adopted this slide from my colleague. It's a comic. Basically, try not to be pretentious, or try not to be, don't try to be clever, because this is a scientific communication. You know, our own purpose is to serve the reader, to make their job easier. So not to pretend and write really lengthy sentences, for instance. You know, it's not, when you are reading it, it's not effective in communicating. It only demonstrates like you are intelligent, but that really doesn't help because the key message is not getting out. Now, of course, engaging, another way to look at it is we need to understand our audience. So far, most examples I've given is related to, for instance, a paper or report for publication. Then we're looking at potential referees, peer reviewers. They're more knowledgeable. Now, if we're looking at a popular article in some sort of magazine, people are less familiar with subject. The tone, I mean, not the tone, but the way you're writing it will be different. You know, not so much jargon. Maybe try to stand in their shoes, understand what, you know, they can see, I mean, how they will view this issue. Now, another important difference, for instance, between writing a paper and a research proposal. A research proposal is trying to market your innovative idea, your team expertise. Quite different from writing a review paper or technical paper. So understanding the audience is pretty important. Just a second. Now, one example about engaging is just, again, write it in almost conversational style. One example I can give here is a paper we published a number of years ago, look at chloride threshold level in reinforced concrete. So we start from some introduction. Okay, the current chloride threshold data in the published literature widely scattered, and the factors defining this threshold is, you know, unclear despite of all the studies out there that raise the need for this study. So the flow of logic is quite straightforward. And then the sections, of course, on methodology, and then move on to results and discussion. So if just look, say if you're a reader and you only have 10 minutes, look at the section titles. It's very self-evident what the story is about. And I think this one won a Best Paper Award mostly or partially because of section 5.5. because we didn't end at the paper just reporting our findings, but instead we talk about the limitations and practical implications of the research findings. So that was really almost holding the hand of the reader step by step. And we say, hey, despite all these limitations, which we talk about, and then we say the findings would be still useful, provide some level of guidance. So the flow of logic between different sections very clear, and the need for such a study was established really early on. And the findings or conclusions are directly corresponding to the things we raised in the introduction. So that's a cohesive structure. Now, talking about abstract, we mentioned a little bit earlier. Some of the journals actually have this structure. They specify what you're supposed to put in the abstract. So this is really helpful. And again, oftentimes people forget to talk much about the limitations of the work or the practical implications. They're just assuming by the end of my study, this problem is solved. Well, there's always room for improvement. Keep that in mind. Now, the third keyword I would say is hypothesis, because there are three types of research: fundamental research, applied research, and development research. For the fundamental research, it's also considered as hypothesis-driven, and it intends to answer the question of why. For instance, we can raise a hypothesis like nanomaterials. For instance, we can be very specific. Nanosilica serves not only as a nanosize filler in the concrete, but also effectively alter the chemical composition of hydrated cement paste. That's a hypothesis. So then in order to test that hypothesis, we can design experiments. And then by the end of the study, we should be able to test whether the hypothesis was true or false. Either way, you're contributing to the knowledge base and you're advancing the knowledge in that field. Of course, this slide is a little bit old now, but today this hypothesis has been tested mostly true. Another type of research is applied research or problem-driven research. It intends to answer the question of how. So on the same subject of nanomodified concrete, then really the question is how to best achieve the uniform dispersion of nanomaterials in concrete, for instance. It's no longer focusing on the fundamentals or mechanisms. It's more focused on the processing or the process. Yet another type is development research or product-driven research. It tends to answer the question of what. For instance, what is the most cost-effective formulation for nanomodified concrete pavement for a certain environment? So since we're focusing on so-called high-quality technical writing, especially in academia, I would say those tend to focus on fundamental research and at least hypothesis-driven, and answering, at least partially answering the question of why. Now, how do we propose, sorry for the typo, how to propose a hypothesis? One way is to look at induction. Induction basically starts from observation and then eventually end up with a theory. For instance, we may observe, okay, the use of nanosilica to, say, replace Portland cement by 1% in concrete tends to significantly improve the strength and durability of the concrete. And then maybe there's other studies look at nano aluminate or other nanomaterials, and then we may reach a hypothesis at the theory level. Maybe it's the nano size effect. And then we can use that to propose new studies, look at other types of nanomaterials, for instance. That's one way to propose a hypothesis, is induction. Another way is deduction. Basically, you start from a theory and then move on to specific examples. For instance, for theory, we know that electrons are pretty important for the health of bacteria. They actually use electrons as a way of getting energy to survive and thrive. So for the bacteria to grow as a community, also known as a biofilm, some of the biofilms can deposit biominerals. So for instance, there's one mechanism being used recently in civil engineering a lot is MICP, microbial-induced carbonate precipitation. Now, knowing that MICP is useful, and maybe we want to better control or regulate how MICP will work in our field. So if we start from the theory, okay, electrons are important for the health of biofilms, then maybe we can use some sort of external pulse electric field with certain frequency to control how the biofilms survive or thrive. So that's a way to come up with the hypothesis by deduction. A third way is extrapolate. For instance, we had a project which stemmed from this hypothesis, is maybe some sort of nano electrochemical treatment will help us get the water out of soil and enhance the strength properties of the soil. And then at the same time, reinforce it with some nano deposition. This started from another different study in concrete field where they made this successful, by applying electric field to remove water out of concrete and inject charged nanoparticles. The concrete became a better microstructure and more durable. So with that in mind, we were trying to extrapolate from concrete to soil because they're both highly heterogeneous and porous material. So that's yet another way to, again, cross the sub-discipline, from concrete to soil, for instance, something to think about. Now, hypothesis is pretty important. So in some of the papers, this is one of my own papers, we actually talk about hypothesis directly. For instance, we say, okay, nanotechnology has been demonstrated, has demonstrated many substantial benefits, and yet the mechanism of modification, especially by nano titanium dioxide, remain unclear, at least at that moment, 2013. So we say one hypothesis to test is mixing this nanoparticle would not only lead to denser paste, but also alter the morphology and chemical composition of the hydration products. Now, this is a very clearly stated, articulated hypothesis. Then we justify why we designed the work plan in such a way. And by the end of the study, we were able to tell, yeah, hypothesis was true. Again, in other papers, like the one I mentioned about manipulation of biofilms through external electric field, because we are trying to regulate the transport of electrons, we also state, this was a paper published in Environmental Science and Technology about 12 years ago. So we say it was hypothesis that polarizing the substrate material will alter the ennoblement process and such. And then to test the hypothesis, we applied this. So it was very clearly stated we had a hypothesis, and at the end of the study, we'll find out whether or not the hypothesis was true. So that was our third key element, hypothesis. The fourth one is logic, the flow of logic between paragraphs. Again, the worst kind of writing is something that even an English editor could not fix because it's convoluted logic. Sometimes, the logic jumping around just like a very artistic movie, but that's not how we do scientific communication. The logic should be very straightforward and easy to follow. Now, that's why a little bit later, we'll talk about the importance of topic sentences. So if, for instance, we have topic sentences for each paragraph, we read from topic sentence to topic sentence. If I only have 15 minutes or 10 minutes to scan through this article, I should be able to follow very quickly what the article is about, what's the innovation. Now, this also flow of logic between sentences. That's a little more subtle than a flow of logic between paragraphs. For instance, a poor writing tends to have the logic, again, jumping around between sentences. So it makes the job of the reader really difficult. You may have to read it 2 or 3 times before you really figure out what the writer was trying to say. Yet another common trap is fragmentation of the message. For instance, one paragraph is trying to tell you 2 or 3 different things. So the reader gets confused. So avoid fragmentation. One paragraph is trying to deliver one message. That's the best case. So again, my personal preference in terms of how to write a paper is to start from outline, especially when we have collaborators. We can agree on the outline or the storyline and structure of thinking, start with topic sentences, and then we flush out the details. Because if the draft was already full of details, it's really hard to revise. Now I've had many of those experiences. So one way to look at it is like how you draw a tree as a beginner, especially. So in scientific communication, we always, kind of be a very humble beginner. So we start writing the paper as if we're drawing a tree. We usually start with trunk, and then we put in a few, or the trunk is the outline, and then we put in some branches. Those are the topic sentences, and then we'll flush out the detail, which are the leaves. So that way it's really easy to follow, knowing that how the tree is structured. Now, of course, the tree can be much more beautiful than this, but it would be really hard for the reader to understand how the tree is formed. So this is the easy way. I would say use the topic list to organize your arguments. And typically, the first sentence of each paragraph should tell you about the key message in the paragraph, which is the topic sentence. Of course, occasionally you would have, the first sentence followed by however, nonetheless. In that case, the second sentence will be topic sentence. Again, a really well-written paper, if I just read every topic sentence in each paragraph, then I should be able to follow the story very quickly. Now, I'm not saying this is the best example, because back then some of these insights didn't really dawn on me. But anyway, this was a paper we published a number of years ago in cement and concrete composites. But you can kind of follow the flow of logic in the introduction. For instance, we start from saying, okay, cementitious material or concrete materials are known to be brittle, easy to crack, under especially tensile stress. And then recent years, the concept of self-healing, there are some advances, especially with hollow fibers. And the use of fiber also have some other benefit in terms of mitigating cracking, control the crack width. And then we say, this work looks at, okay, the potential synergy between the microfibers and some of the self-healing materials like microcapsules. So the flow of logic between paragraphs very clear. There's no jumping around, it's a linear flow. Now, it's always important to use a topic sentence when you're writing a paper. Sometimes we tend to forget. For instance, this was a real example. You can see track changes. A paper we actually published in Journal of Cleaner Production recently. So the original draft, you can see that we're talking about different case studies, but there's no topic sentence. So a reader will have to read every sentence in this paragraph before figuring out what you're trying to, say or deliver. So with this one topic sentence, it becomes really clear. Okay, this whole paragraph was talking about this issue, proper citing of infiltration best management practices as a BMP or a stormwater best management practice. So this was a previous concrete paper review article. Now, in another paragraph, the same thing, we had many case studies trying to support one message, but that message was not articulated in the beginning. So I added this one topic sentence, just saying the last decade has seen increased use of pervious concrete pavement and the maturation of its design fabrication. Then we start with the topic sentence, the additional sentences to support the topic sentence. Now, the other thing is to facilitate the flow of logic between paragraphs, we should use transition paragraph and summary paragraph. For the sake of time, I won't get too much into that detail, but again, there is a need to have such transition or summary sentences. Now, the flow of logic between sentences is really subtle. I give one example here. Again, I think the slides will be shared later, so I won't get too much into that detail. But again, imagine if you move the order of some of the sentences, then it will be really hard to follow. Just remember that trunk, branches, leaves. That's the best way to write your story. And from this book, they also suggest something very similar. Start from outline from a concept sheet so that you figure out your storyline and then topic sentences, and then you flush out the details. Yet another key element is synthesis. what I mean by that is when we are writing a technical manuscript, for instance, the common mistake, especially civil engineers tend to make, is that we forgot to talk about other people's related work. So by the end of the reading, the reader won't know the whole overview of this field. They just know your study or our study. So in the resulting discussion, there needs to be some discussion. Oftentimes, people only focus on description. They describe the results, the trends, the interesting findings, but they forgot to compare, contrast, and reason. For instance, in this study, we say, hey, this finding is consistent with the previous study. In some cases, we say, well, this differs from this other study. And then we hypothesize or reason why the difference. Maybe they use a different water-cement ratio. Maybe they use the other chemical which interfered the findings. Maybe they misinterpreted their data. So by doing that, you're helping the reader, again, to look at how this finding fits into the bigger picture and advance the overall knowledge base. Now, when we write a review article, it's even more important to have synthesis. This was a relatively good, well-written review article we published a number of years ago. So we had a section on looking to the future. For instance, we synthesized what's out there with some summary table, as you see in table 1 at the top. And then in the section of looking to the future, we talk about the common trends. So we talk about, like the trend of integration, automation, barriers to implementation. And again, the key there is not to simply list, okay, study A said this, B said that. There needs to be a level of synthesis. Use your educated knowledge and provide insight. So there is a need to compare, to integrate, to evaluate, to correlate, to reason. And that's the benefit. Again, a well-written review article should help the reader get quickly familiar with the overall landscape, where things have been, why it was important, where things are missing, where things are going. Just as if you're standing at the top of the mountain and look at the valley, and this article should provide that, that kind of information and guidance. And then also maybe there are a few inspiring thoughts when you talk about looking to the future or knowledge gaps or research needs. So that basically differs a well-written review article from, the so-so ones. And oftentimes, even in a technical manuscript, we don't necessarily always call it conclusion. We could call it concluding remarks if we provide additional insights or discussion points which are not directly supported by data from the experiments. So for instance, in this permeable concrete pavement review article, here are my original thoughts in terms of what to include in concluding remarks. I said, well, once the previous sections are finalized, revise this section so it captures the topic sentence from each previous section. Again, that would be so much easier if we had written in such a way we know what the main storyline was. Of course, we should not simply repeat those sentences. We should rewrite, maybe even implement some level of synthesis here to retell the key messages. And also try to add some text about remaining challenges. That's where your educated insights are. For instance, we talk about, okay, durability of pervious concrete in the presence of de-icers, especially when the pavement accidentally collects some de-icer-laden runoff from adjacent impervious pavement. We also talk about detrimental effects of sodium chloride and magnesium chloride on the durability of concrete, because some of those issues are still not clear. So it merits further investigation. Also offer some direction for future research. That's what a good review article should do. Talk about the need to better understand this material, its hydrological behavior, deterioration process at different length scales. Use nanoscience, use nanoengineering. So, again, you see the point. Concluding remarks is a little bit different from conclusions. Finally, the last keyword, last but not the least, is details. I would say the easy way to pay attention to detail is write with your heart, wholeheartedly serve your audience. Don't do a lousy job. Just, pay pay attention, write with professionalism. Again, this is like a professional conversation you're having with the reader. So the attention to detail will make a huge difference. If the graphics are made very poor quality, if the manuscript is full of grammatical mistakes, then it won't make a really good first impression. Same thing with technical proposals. Some proposals fail for that simple reason. People don't want to read it further because it doesn't look good or doesn't feel good. So it would be sad to lose that opportunity just because of these little details. One way to get better is to learn from best examples. Accumulate your vocabulary so that you can write in a simplistic way. Now, again, we talk about trying to be conversational, not be pretentious, not pretending to be really clever, but that doesn't mean you have to be monotonic. Monotonic, like if you have very limited vocabulary, you end up using the same words over and over. It's really tedious. Of course, we talk about the importance of paying attention to grammar, and there's also some issues with subtlety. For instance, a well-written paper, you should be able to read out loud. The length of sentences should vary so that almost like a song. So if a very lengthy sentence you cannot finish in one breath, then something is wrong because the reader won't be able to finish in one, split second. They will have to pause and rethink that sentence. So there's some subtlety about the melody or the length variation of the sentences. That's really, really tricky. But again, learn from the best examples. If something reads really well, you want to try to understand and do some sort of reverse engineering why this paper reads so comfortable. There's also a certain level of elegance that's probably even more subtle. But it takes experience, practice to get to that level. Now, detail is important because, again, we talk about the possibility of desk rejection. Some of the papers are not sent for review because of the poor formatting or graphics or grammatic errors or whatnot. And the top journals may even have a high desk reject ratio of 90 to 10. So basically, out of 100 manuscripts, 90 of them are desk rejected right away without going for peer review. I think that's a good practice because then it's not wasting reviewers' time. Because if you are not, paying 100% attention to the manuscript as an author, why should a volunteer, help you fix those problems? Now, we talk about details a little bit and subtlety. Well, sometimes the title is also important. For instance, this self-healing paper, a self-healing concrete paper, was widely cited, partially because of the title, because people can easily understand what you're trying to say. Say if our title just said, hey, a novel type of self-healing concrete, that won't be very evident. They will have to read further to understand what exactly do you mean by self-healing concrete. And also the subtlety is in the use of words. Like, for instance, you can see we use the word substantial versus significant. These actually do mean different things. Substantial is a lot more substantial than significant. Significant often carry a statistical meaning as well. Maybe you should talk of vocabulary. Also, there's a good book. I selected a few things out of that book. It's talking about the common habits from more than 200 English papers written by graduate Chinese engineering students. So for instance, for one thing, we already talked about avoid very lengthy sentences. And also when there's too much detail, better come up with a table instead of describing in text. Also always place the most important subject at the beginning of the sentence. That would be a good practice. Actually, I've made this mistake before, like not putting the most important message in the beginning. Again, we're talking about making the job of the reader easier. So same thing with the idea of topic sentence. Even within the sentence, put the most important message in the beginning of the sentence. That concludes my talk. Again, just to refresh your memory, 6 key elements: innovation, engaging, hypothesis, logic, synthesis, and details. I think the slides will be shared online along with the audio file. And now I welcome your questions. Thank you.
Thank you very much, Dr. Shi. Excellent presentation. Now, if you have any questions, please type into the questions boxes, and we still have some time to address your questions. Any questions?
No, try not to be shy, because that's the whole importance of webinar or communication is to get the message out and help others. So if you raise an interesting question, that might actually benefit other people as well. I know many of the audience probably grad students who are not used to this kind of format.
Xianming, maybe you can share especially for our graduate students or young professionals, for example, when they studied their first paper writing. Do you want to share your, I know this is a, for everyone, this is really a process of learning and continuous learning, and also experience matters. Do you want to? Oh, okay. I'll ask you this question later because I see questions now. I'm not so sure. Okay, this question is: can you talk to the length of papers? So I'm not exactly understanding this question. Can you talk to the length
of the paper? Yeah, of course, this technical note versus the conventional papers. But again, I know in Chinese media, Chinese journals, there's always a very strict rule on the length. So that makes it really difficult to get the full story out. I think the bottom line of good writing, at least, is that anybody in the world should be able to replicate your procedure and your findings. So without sufficient length, sometimes that's impossible. In most English journals, there certainly is a rule of length. Cannot be too long, but usually that's pretty relaxed. I think 10,000 words, very common. Up to 10,000 words. The important thing is to get the message out, and also many journals have this additional what you call the additional information or supplementary file, like especially for environmental science and technology, for instance. You can look up their website. They have the main manuscript, but then they have all the additional information. Now for corrosion science, for instance, they also have maybe they don't publish that, but when you submit to the peer review process, they ask you to provide the link to your raw data and the process data. Maybe that was more for ensuring the integrity of the data. But anyways, yeah, just think about there needs to be a way that people can replicate the results. So if you don't provide all the details, well, either intentionally hiding or unintentionally, that's not helpful. So, so many people, actually, when I was new to the English journals, I was surprised that the introduction could be really long. Like myself, I think the paper I published in Environmental Science and Technology, my introduction was maybe 2 pages long. So it was almost like a mini review.
I think most important things is to describe your story. You have to provide a clear message to the reviewers, to the readers about your work, and then generally, as Xianming also mentioned, for different journals, they have their own format requirement, you can find from author's guide. Some have specific requirement in terms of length, but I think the key is you have to, you have to give a complete message of your work. Otherwise, it won't be a good paper, right?
Yeah, and also I can share another story about length, which was interesting because I had a paper which was kind of, outcome of a large research project. So it was so long, I decided to divide into two papers, like part one, part two. Then when I submit to this journal, they say, well, no, make sure you combine them. So I end up having a very lengthy paper. I don't know, maybe 15,000 words. So in that issue, they only had maybe 4 papers, and mine took 50% of the space. But they had a good reason because they think, okay, if you divide it, then the message is like fragmented, But of course, you will see a lot of papers like part one, part two. If you can divide it clearly without hurting the message, like they could be separated, then that's okay.
Okay. Next question. Could you please recommend a book for the subject of writing papers?
Wow, good question. How about this? I'll try to do a little bit of research. I remember a few, but now it's kind of escaped my mind. So I can send that to Professor Liu, and she can put on the webpage.
Okay, that will be very helpful for attendees. Thank you. Next one. Hold on a second. Where's this page? You mentioned a paraphrasing is considered as a fraud process.
Okay, I get the question.
Hold on a second. Let me. I'm just trying. I don't know why the question is not the. Cannot see the. Yeah, maybe the question is not complete. I think the attendee is asking, if you mention paraphrase is considering the fraud process. So generally, for example, when we write in introduction section, which is kind of a literature summary, how to write to avoid this kind of issue.
Okay, so let me just elaborate on that a little bit. So, like I said, it's a very subtle way of fraud, because when you run a software like anti-plagiarism tool, you probably won't catch it. But I think in the future, however, with artificial intelligence, I think the software will get smarter and they will be able to capture that. And also, again, a lot of people don't know this rule. Say we're trying to avoid plagiarism, but say we're telling the same story, just we change a different word, maybe having the same meaning. But the thing is, if you're paraphrasing using the same sentence structure instead of writing your own way of thinking, that's actually plagiarism. So the way to avoid that is understand the message, then write it in your own understanding, not just trying to simply replace a word, with a different word. Instead, you should basically write starting from afresh. Another way to avoid that is like, especially in terms of review article, you should, so your sentence should be supported or derived from more than one source. So maybe study A did this, study B did that, then you kind of synthesize the information right in your own words. So in other words, the paraphrasing here is talking about following the same sentence structure, even though you change the words. That's paraphrasing. Again, the general rule, I believe, is that, I know softwares have different definition, but usually if you have 5 or 6 words in a row directly copy it from somebody, you better quote, otherwise considered as plagiarism. That's what the softwares do. Some software even look at true words, identical to some other paper. When you look at, depends on which tool you use. But now paraphrasing is more subtle. Again, copying the sentence structure without thinking, basically you didn't digest it. If you digest it, you can write in your own way. Now hopefully that clarifies.
Okay, I think we have a lot of questions. Some of them relate to where to get the slides and if we're going to share presentation stuff. So let me just answer all one time. The presentation is recorded and will be posted on websites of CESTiCC UTC, Inspire UTC, and I think also ISCIP website. So I don't have a list of attendees. So that's the way we're going to share with the public through the websites of these 3 units. Okay, let me back to Xianming's question. How do you think of the open access the journals?
Good question. It's a mixture. Open access doesn't mean it's a predatory journal. The way to tell is, let's say the upside of open access, of course, usually is a little bit quicker than traditional publishing and more visibility and citations because people don't have to pay to get access to the journal. But then the cost is on the author, not the reader, I guess. But then there are a lot of predatory journals. You can even search predatory journal. They have basically a blacklist. The simple way to tell usually is like whether or not the journal has a real peer review process. If they promise you this paper will be published no matter what, then something's wrong with this journal. And the second is whether or not they will they will charge a fee to guarantee publishing. How do I say this? So in other words, a reasonable journal, they would still have a chance of not publishing your work and not charging a fee. They only charge a fee when your paper is accepted and formatted and they actually did work on it. And also you can tell usually from the look and the feel of the email, their website, and which publisher it is. There are, like I said, there's a blacklist of predatory journals, but there are some of the journals are kind of in between. It's sometimes they're on the list, sometimes they're off the list. I don't want to mention any names so that I avoid all the trouble. But you can tell actually if you do a little bit of research, and again, mostly the open access journals offer the benefit of better visibility. If you want to get the information out quickly or more widely, that's a way to go. I honestly think the future will be more and more towards open access journal. But right now, the business model is a little bit problematic because it's too expensive and people are making too much profit.
Okay, next one. Is the simplicity of writing may conflict with the content of writing, and how to combine both good writing and strong content?
So it's good writing and what?
And strong content. I assume the attendee is asking, how to make your writing simple, but with clear
Simple
message.
Right,
yes.
Yeah, I get the idea. We talk about it can be simplistic, but not monotonic. Monotonic is like, okay, as temperature increases, this increases and levels off at this point. You always follow the same structure, and there's no, let's see, how to avoid that. First of all, expand the vocabulary, expand your sentence structures. When I was new, I would read good articles and then take notes. Okay, this is good. word, or this is a good sentence structure I could potentially use. But now that's not called plagiarism because you're not, taking directly from that, but you're accumulating that kind of knowledge, eventually become your own. Like now when I write, I don't have to look up any notebook or anything. Just like, okay, I'm just like having a conversation, write as if I'm just talking to you. The opposite side of simplistic is trying to be clever. Like this comic was talking about, pretentious, lengthy sentence structure and unusual words. So in other words, your writing could be simplistic and still communicate very effectively the content. Again, one way we talk about the outline. One way to start a story, actually, I would ask my students, PhD students, to start from PowerPoint, because then they're forced to focus on the high-level information and make sure the logic flows clearly. And then once you get to the details of fleshing out the leaves, we were talking about, going beyond the branches to leaves, that's where you can be simplistic and still elegant. Again, the easier way to learn is just learn from best examples, accumulate your thoughts, always have some sort of notebook on hand to accumulate those kind of things as a beginner. And then practice, write a lot. I think my English writing really improved when I was a grad student, 20, 30 years ago, when I started writing a diary in English every day. I did that maybe for 1 or 2 months, but that was really helpful because then you accumulate a lot of vocabulary. Everything you learn today, you try to use it tomorrow. So that's probably most effective. I hope that answers the question, but there's no magic. I mean, there's really just a lot of hard work.
I think a very good answer, and practice makes perfect. I think it's really always that I mean it's a process of learning and practice and yeah, it's a continuous process. Xianming, I found a very good question. Oh, I lost the question. It's about the in review paper, we represent works of other authors. What is the best way to write a review paper without plagiarism? I think you certainly have experience.
Sorry, could you repeat that question?
What is the best way to write a review paper without plagiarism? Because in review paper, we have to, represent
right.
Works from other.
Again, just keep in mind the purpose of the review paper, because there are so many review papers out there, right? So I think my personal opinion is that a good review paper should introduce the subject to an unfamiliar engineer or scientist very quickly. So if I read your review paper, I don't have to look at the other 100 papers, but I already have a very good handle on the overall, again, overview of the landscape, as if I'm standing on top of the mountain. Why the subject was important, where things have been, where things are going, where things are missing, where things are going next. To avoid plagiarism, of course, again, like I said, well, my procedure for my students usually is ask them to come up with a list of references by keyword searching in Google Scholar and other databases, and I will look at that list because some are from less credible sources. I will discard them, and some maybe and also they will target certain journals to do a more in-depth search. That's a beginning step, and then I will ask them to look at the abstracts, conclusions, to again scan through the papers, not reading every sentence, to come up with an outline. And then if we agree on the outline, or maybe they're missing certain parts, I'll give them some new keywords and they'll start from there. And then we'll start from the outline and topics and stuff. Now to avoid plagiarism, I think it's just digesting the information and rewrite in your own way. Because basically what I tell them is like, say, if you end up with 50 or 100 papers, for each paper, you're basically how do I say this? Disintegrate them. Probably just tear the paper apart, right? Like this piece of information could go into my existing structure of 3.1 or 3.2.3. So in the beginning, as beginners, they can always use the original writing, even take that sentence, dump it in there. But what I typically recommend is to start from a summary table of some sort. And then once they have all the information, all the pieces, then they can start digesting and then rewrite in their own way, tell their own story. And then even have your concluding remarks and stuff like, okay, look at the overall picture, you can see where things are still missing or unclear. So again, writing after digesting the information, not simply copying the sentence structure and then replace the words. I think that's probably the way to go.
Thank you. Hey, Xianming, please make your answer short because we have 8 minutes left. Okay.
Okay.
We still have a number of questions. Next one, you mentioned that we should use a topic sentence, but in some cases it's not easy because only one point might not be enough for a paragraph. For this situation, do you have any suggestion?
Good question. But usually I would say that's because you didn't look at other literature. Of course, you will have a scenario like you have an interesting observation, but there's no relevant literature or anything. So just one sentence. It's topic sentence, that's its own paragraph. That's possible. But I think in most other cases, it would be better to stick with one topic sentence and supported by multiple sentences so it forms its own paragraph. The way to do it is, again, not just describing your results, but compare against other relevant studies. Like, okay, compare about the values, their trends, why they're consistent or why they're inconsistent, and what's missing, and maybe even hypothesize where it needs more additional work. I mean, again, go beyond the description of the results alone. So, but that's a little bit tricky, but it's case by case scenario.
Okay, next one. What's your opinion about posting preprint in some website, for example, arxiv.org or engineerxiv.org? It's getting popular, but not sure how much it's valuable to post the preprint.
Got an idea. I've never done that because in engineering, the review takes a long time. Some of my papers went through a 3-year review period, which was crazy. So if we post the stuff too early, it might be dangerous. So I'm not sure. So that's where maybe the open access journal is the better way to go if that journal is from a decent publisher.
Okay, next one. Some software that can check grammar, how can be effective in some software that can check grammar? Have you ever used such software? What is your recommendation? I bet you not.
In Word, they can also help you check grammar, but the grammar issues are less critical, I would say. You can always legitimately hire an editor, pay, I don't know, $20 per page or whatever to fix the grammar. Even some junior faculty do that. But the more important thing is the innovation, the flow of logic, those kind of things. But again, with enough practice, the grammar issue eventually, disappear because you can document what common mistakes you keep making, so you can focus on those.
This is an interesting question. How will you advertise your published research paper?
That's a good one. Well, I think webinar is one way to go, right? Like you can talk about it and then again, in today's world, people are busy. So webinar is a really good way. Social media. Again, I know there are some copyright concerns, when it comes to ResearchGate and academia.edu. I think building your own social network would be the best way, and be active in society, like SE or ACI.
Okay, yes. I think for young professionals, always don't forget to promote yourself. And like say, for example, if you are active in Facebook and other social media, and once you publish paper, okay, you post it there, and sometimes I think for some journals, it allows people to free download the PDF file within a certain time period. So that's a way to to showcase your work.
Also, don't forget IICIP. We can help you if you have really interesting work. We can put in a newsletter or social media or WeChat.
Oh, that's good. Okay, this one I think probably in every university has a guideline. In the dissertation proposal, do we need to have a section for the abstract, or just start with the introduction? I think dissertation, I think always we have a section for the abstract. That's for sure. Okay, I already answered this question for you, Xianming. Could you please tell more about different types of papers? For example, short paper, technical note, something like that. We have 2 minutes left.
Yeah, technical note usually is something, it's not fully investigated, but you want to get the news out. And by itself, even though it's short, but the story is solid, it's interesting. So sometimes there's also another type, which is case studies. But case study, probably more practitioners doing that type of publication. But a full-blown, regular paper is something that basically clarify a lot of things. But sometimes the technical note is just raising interesting observations and maybe say, hey, this needs further investigation. When you submit, you kind of know by the length or by the level of detail you have. Again, just make sure the paper itself has value. I think that's the bottom line, is with or without this paper, whether or not this field will be different.
Okay, we have.
I didn't provide a full answer, but
well, 3.
When you read enough, when you read enough, you can tell the difference between different types of papers. Always read good papers, so you don't waste time on lousy papers.
Some more questions maybe I think will be also addressed in our next webinar series. Do you think I can use one experiment result in 2 papers?
Only if you cite the previous paper, and only if you have a different interpretation, like you found out you were wrong, you can point that out. Or you have basically you cannot hide the other paper. That's the bottom line. Okay.
This one is easy to answer. You mentioned that try writing papers by starting with the results discussion, then conclusion, introduction, followed by the abstract. I would like to know, would this structure be accepted by the reviewers of the journal, as this structure seems to be very unconventional?
No. I was talking about the order. The structure will be still the same. Right? You'll still start from introduction and whatever. I was talking about the order of writing the paper, and the reviewer won't know which section you start first, right?
Right. Okay, we have one last. There are some websites that can detect plagiarism before publishing a paper. How are they good in detecting? Can you introduce some reliable websites?
Reliable website?
Yeah, websites.
No, again, we usually run through those. I think I can send a link since we're running out of time. But again, if you put your own thoughts into it, I don't think there could be very little accidental overlap with other people's writing, right?
Okay, because since now it's already 11:31, I don't want to keep Dr. Shi for too long. One last question, and also if you have more questions, and I think you can also will always feel free to contact Dr. Shi, and the last slide has his contact information. But there's a last question. When do I know I have researched enough to start writing?
Good question. Actually, when you do literature search, I mean, for a journal article, you actually do literature search at different times, several times. Before you select the topic, right, you make sure you are not reinventing the wheel. And also when you're doing it, you run into difficulty. You may try different keywords, or you come up with new ideas to search for a test method, for instance. And when you're writing the paper, describing your results, again, when you get into discussion, you need research again, right? So research is all about search again, right? By definition. So you search again to make sure you can compare your results with others and discuss it. Don't just talk about your own story. Put that into the bigger context. I hope that clarifies.
Okay, thank you so much. Again, and very appreciate Dr. Shi's time and the great effort to provide a very nice guidance for graduate students. And also, I really appreciate a lot of discussions here, a lot of questions. And again, the webinar is recorded, and we will upload on the websites of CESTiCC, Inspire, and IACIP. Please also don't forget, we have our second webinar on technical writing on March 22nd, 2 weeks later, still Friday and still time slot. And I think Professor Ji Han will give you guys, graduate students, give attendees more details about the general guides to publish a well-written technical paper. Thank you so much, and have a good rest of the day. And see you later. I think see you in 2 weeks. Bye-bye.
Thank you, everybody. Thank you for your time. Goodbye.
Bye-bye.